Hello viewers, welcome back to this course on scientific computing using MATLAB. So, this is the third lecture. So, in the previous two lectures we have started with the basics of the MATLAB, and now today we will talk about that how, because in the previous lectures we have done the numerical computation in the MATLAB. Today we will talk about that how we can do the symbolic computation in the MATLAB. So, let us start with the MATLAB. So, today we will talk about the symbolic computation. So, symbolic computation means that now we can define the variable as we usually do whenever we are doing the analysis or in the mathematics books. For example, I define, so this is the symbolic computation. I will define, so SYM means the symbolic. So, help sims. So, it gives you that the sims is a shortcut of constructing symbolic variable. Now, I am defining that my variable x is a symbolic. Okay. So, similarly, I can define the different variables like this one here. So, I can define, so I have defined the variable x. Now, suppose I write y is equal to x square. So, this is another variable, and this variable is also in the symbolic form. Symbolic means y is equal to x square, because we know that in the mathematics we always write y is equal to x square is a function, y is equal to sin x is a function. Suppose I define y is equal to sin x is another function. Now, if I want to check that what is this, so it is given that f is a 1 cross 1 size function, bytes is 112 and class is symbolic. In the previous it was showing the double, because it is the numeric value. So, it is the, that is why it is showing that it is given in the double form bytes. So, x is also the symbolic with the 112 bytes, y is also the symbolic. Now, suppose I want to define that just I want to find the SOLV is solve. I want to solve this quadratic equation. Suppose I want to solve x square minus 1 and this is equal to 0. So, that gives you the answer. So, it solve this equation x square minus 1 equal to 0 symbolically, and I get the answer minus 1 and 1. Suppose I want to define another equation, x square minus 2 star x plus 1. So, this is the equation I have defined, and I want to solve this one. So, that is the roots I am getting, that is 1 1. So, similarly I can define another equation. I just want to check the complex roots or maybe real roots. So, this is the root I am getting. Now, suppose I define like this. So, this is the roots we are getting, that is in the third form. This is the minus 1 and minus 2 the repeated roots. Suppose now I define another equation, x square minus 4x minus 4. So, this is the another roots I am getting, 2 minus 2 raised to power 2 minus 2 into 2 raised to power half, means under root 2. So, that is the value we are getting. Suppose I want to solve another equation like this one. I define the equation like this. Now, colon x square is equal to 3 star x minus 5. So, this one I write with the semicolon. So, that is the answer. Warning, do not specify equation and variable as character string. So, that is the answer we are getting in the terms of this one. Or maybe the same equation I can solve, because here I am putting the semicolons, but the same equation I can solve by minus here and plus here equal to 0. So, this is the equal to 0 we have to write double 2 times we have to put equal sign, and that gives you the solution. So, this you can see that the solution these and these are the same, because we this was another way we have written, in which we are using only single equal sign, but we are putting the equation in the semicolons. But here we are putting the equation in this form with the double equal sign. Now we can define maybe another equation. I can write x plus y. So, I defined another variable sym sims y. So, y is another variable I have defined. Now, I can show that x plus y multiplied by x minus y, and I want to see the answer. So, that is the answer, x plus y into x minus y, or I can write this as expand answer. So, that is the, because I know that x plus y into x minus y can be written as x square minus y square. So, I can write that whatever the answer we are getting, I can expand this one with the help of the command that is expand, or maybe now what I can do, I can again factor the answer. So, that is the factor we got. So, that is the same one, x minus y into x plus y. So, expand means I will expand the answer in the compact form, and this is the factor, we can do the factorization of the given equation. Maybe I can define another function, another command, like I write simplify. So, I define the command that x cube minus y cube, and then, so this is the bracket I have to put, divided by x minus y. So, this is the command we have done. So, that gives me the x cube minus y cube divided by x minus y. So, the answer is x square plus xy plus y square. So, using the help of simplify, because otherwise if I write the command like this one and don't write the simplify, the answer will be this one, x cube minus y cube by x minus y. But if I want to simplify, then it will cancel out whatever the common term is there, and it will give you the answer after cancelling all the common terms. Now, this is the way we can define. Now, I can even plot the functions with using the help of EJ plot. So, let us define this plotting. So, now I define help EJ plot. So, EJ plot, you can see that EJ plot is easy to use function operator. EJ function plots the function x over the default domain. Okay. So, let us use this one. So, I write EJ plot. Suppose I want to plot a circle. So, I define this one, between the interval I define. So, I take minus 2 to plus 2. This one. So, there is a bracket EJ plot x square plus y square, and then comma we have to put. So, that is the EJ plot. So, this is the plot it is showing, x square plus, maybe this is a 2-dimensional. So, I just define the first dimension only. So, I just write x square plus 2 star x minus 1. So, this is the plot. So, this is showing that this is a plot of x square plus 2x minus 1, or I can define the plot of x square x cube plus x square minus x in the same domain. So, it will give you the plot of that function, because sometimes we want to plot want to see the function, so we want to plot that function. So using this very simple command we can plot any function. So what I want to plot, instead of this one I want to plot sin x. So that gives you the value of the sin x. I can change my command this domain, so I can take from minus 2 pi to 2 pi, and that is the function we got. So this is the value of the sin x between minus 2 pi to 2 pi. So this one we can do. Maybe we can plot another function, sin x multiplied by cos x. So this is the value of the plot of the function sin x into cos x. And now suppose I take the hold on. So hold on this graph. So I can define now the same command. ejplot is coming. Now I take another plot, and instead of this I take minus 1. So that is the plot we are getting. Or maybe I can give the name to the figure. So I first define the figure 1, and then I give the command hold on. So this is the figure 1, and I just hold on, and then I plot the graph. So that is the plot of the graph. Then I define the another plot of the graph, just sin x. So this is the another plot we are getting. So that is the sin x, and this is the sin x into the cos x. Using the help of hold on, I can hold the same graph in the figure 1. So I have given the name to this plot, that is the figure 1. So that one we can do. So that is the help of with the help of ejplot we can plot many functions. Now we do some another symbolic calculations, because this type of calculation, if you see, earlier it used to be done with the help of Mathematica or the Maple, but now this is also possible in the MATLAB. So MATLAB is being used now widely for both numerical computation as well as the symbolic computation. Now suppose I take the help, and then I write substitutes. So it shows you that substitutes is a symbolic substitution. So in this case, suppose I have the equation, I write substitutes, and I write, suppose I write x square, this is my function, and I substitute x 2 here. So that gives the value of the 4. So how we can define the value of the substitution, function substitution. So substitution is that this is the function we have, and that is the variable which is giving the value 2, and that is the answer we are getting. I can define the substitution of x raised to power 3, and so that is the value of 2 raised to power 3. I can define the function sin x, and then x I can put maybe pi. So that is the value of g. I can define pi by 5. So that is the value of the sine function at pi by 5. Or I can define the value of the function at pi by 6, that is half. So using this one, I can substitute the value of the variable in the given function, or that is also possible that I define the function. First I define the function. Suppose I define the function x square minus y square. So this is my function, and now I write substitute ff x is equal to 2, x 2. So this gives you the value of the function, that I have the function ff, and in that function I put, instead of x I put the x equal to 2 in the given function. Now I can define the same here and I can add answer, and then I put y is equal to maybe 3, and that is a minus 5. So it gives a 4 minus 9, so it is a minus 5. So I can substitute the value of the different variable in this one. Even I can define this substitutions. Now with the help of this symbolic computation, even I can plot another something like I can plot EJ plot at the rate maybe log x, and defining the plot from 0 to 10. Suppose I want to plot this function. So this is the, so like this one I have done. So I can use here my log x. That is the value of the log x we are plotting. Now maybe I can define the another function. So this is the pi we can take from here. Now I want to define the pi by suppose 2 value. So that is the value we are getting. So this is pi by 2, we know that this value is 0. So in this case I am getting the value 0, and that is given by e raised to power minus 17. So this is the how we can define the little bit of symbolic computation. Then so let's plot another variable or another function. Suppose I want to plot x square plus x minus 3, and I want this to be done in the interval from 0 to or from minus 2 to 2. So this is the plot we are getting. Now I can also define the same way title we have done. So x label. So x label will give you, so this is I just write capital X axis. I can define y label as y axis, and now we can see that this is my function. Even I can, because this is giving me the blue color, even suppose I want to change the color of this one, then maybe I can switch to edit, and then I can see that the figure properties, and with the help of the figure properties you can see that I can change the color of this. So that is the function we have. This is the graph of the function, and it gives you that you suppose I want to change the color of this line, so I can put it is a black. Now suppose I want to increase the, because this is a very thin layer with the 0.5 line width, so I can increase the width by 2. So this is the, that it become the bold one or dark one. The marker is there, I can even change the color of the marker. So this is the my function, plot function, and suppose, so this is the way we can take the axis. I can take the axis anywhere. Now suppose this is my y axis, I can change the style of this y axis. This one. So y axis, even I can write here like this one, I can edit this one later on. So this is my y axis, this is my x axis, I can take this one and then I can do the changes. So this is my title, I can move this here, even inside the graph I can move this. So with the help of editing you can edit your plot, whatever the plot you are getting, and suppose in the later on you want to make some changes, because in that case you are not going to reproduce the same plot. So, you can do the editing with the help of this edit of the plotting. Now, suppose I have done with this plot and I want to save this plot. So, this is the file and we can save this as. So, it will ask you that where you want to plot. Suppose I want to plot it in the NPTEL and this is my. So, I can write here I want to plot this one as figure 1. So, figure 1 I want to plot in the name of figure. So, that one is saved now. Suppose I want to use it later on in my paper in the LaTeX or in Word file, then I can also save this as. So, here we can, these are the different extension we can save our figure. So, this is BMP, EPS, JPEG. So, all these different styles we can, because in the LaTeX we generally use the EPS file. So, I can save this function as a EPS. So, this is the function is now saved in your file with the EPS extension, and another one is saved in the form of fig function. So, this is different way we can define the given plot. Even I can insert, suppose I want to insert, so I want to insert the arrow or the text arrow. So, text arrow means suppose I want, so this is the figure here. So, that is the figure and here I can write by inserting the text arrow. Now, here I can write the value of the function. Function is equal to x square plus x minus 3. This is the function I am getting, or maybe I can, I do not want to write this function here, maybe I can delete this one, or I can move this function, this here, this one. So, that is the plotting, and this is the text arrow that showing that this is, because suppose we have a large number of plots in the same plot, we can tell them or classify them with the help of the arrow function, that which function represent the which functions. So, this is all we can do with the, now we can insert the ellipse, we can insert the arrows or the line. So, suppose I want to insert the ellipse. So, this is the ellipse I am getting, or maybe I can insert the circle here, later on we want to insert. So, and this is the views that maybe I can insert axis. So, axis I have already inserted here, but if suppose we forget to insert, then later on we can insert this axis here. Maybe I can insert a rectangle. So, this is a rectangle, or maybe I can move this rectangle from here. I can insert the rectangular box like this one, or maybe I can insert the. So, this one we can play with this plot. Once we are done with the plot, then we can even make the changes, we can play with this plot, and we can change it, whatever the changes we wanted to make later on, we can do that one. And then we can minimize this function, and from here I can delete this one. And now I can see that what are the variables. So, all the variables today we are dealt with is the symbolic computation, and I can even clear my screen and I can clear all the variables. So, that is gone. So, this is all about the symbolic computation. This is the basic about the symbolic computation that we can do with the help of the MATLAB. So, in the next lecture we will go little further with the basics of MATLAB. Thanks for watching. Thank you very much.